Hello, we're continuing with 9.5, matrix operations. Before we do matrix multiplication, I just want to mention one thing that I forgot to mention when we were doing matrix addition, and that is you can't add or subtract two matrices unless they have the same dimension. So it has to be a 2 by 4 and a 2 by 4. You can't add a 2 by 2 with a 2 by 3. Like they have to have the same dimensions. But with multiplication, that's going to be different. So when we're multiplying two matrices, the columns of the first one have to match the rows of the second one. So if you have them set out next to each other, it's the inner dimensions that need to match. So the inner dimensions need to match, and then the resulting matrix will have the outer dimensions. So the resulting matrix of these two is going to be a 2 by 3. Now, so with that in mind, that means that if this is A times B, that's not going to be the same as B times A, because look at this. B is a 3 by 3, and A is a 2 by 3. So if I try to do B times A, my columns doesn't match the rows here. So I can't even do this multiplication. So A times B is not necessarily going to equal B times A. In fact, sometimes A times B is defined and B times A is not defined. So when we're looking for our matrix multiplication, the first thing we need to check is, can I even do this multiplication? Do these inner dimensions match? And then if they do, then we can go ahead and do the multiplication, and our result will have the outer dimensions. So let me write out another example of that. Say my dimensions are, say I have a 2 by 3 and a 3 by 1. Say these are the dimensions, and I want to multiply these two matrices. I can do that because the columns of this one matches the rows of this one. So I can do this multiplication, and the resulting matrix is going to be a 2 by 1. So I can do this multiplication, and the result will be a 2 by 1, will be the outer one. All right, so with that in mind, let's look at how matrix multiplication even works. So looking at these two, matrices here. So these are the matrices with these dimensions. So I can do this multiplication. To get my resulting matrix, I do it element by element. So to get my first element, so say this is my resulting matrix, I'm going to call the first element C11. So let's just say A times B equals C, right? I'm just going to call it C11. That's my new one. To find C11, I have to do the dot product of the first row of A and the first column of B. So that's what they've got down here. Row 1 of A, column 1 of B. And I'm doing a dot product, which basically just means I multiply the first one times the first one, plus the second one times the second one, plus the third one times the third one. And that's a dot product. So I'm doing the dot product of these two. And when I add all those together, that's going to give me C11. So then to find C12, I want to find C12. I need to take the first row of A, dot product with the second column of B. So these numbers tell you what it is that you're looking for here. So it's the first row of A times the second column of B. First row of A, second column of B. And again, I multiply the first one plus the product of the second one plus the product of the third one. So multiplying and adding all the way down. And we will do actual examples of this with numbers, and hopefully that will make it more clear. But you do that all the way until you have your 2 by 3 matrix. Okay, so let's do an example. So this is a 2 by 2 matrix. These are both 2 by 2 matrix. So this has 2 columns and this has 2 rows. So I can, in fact, do this multiplication. And I'm going to get a 2 by 2 matrix as a result. So let's go ahead and do this. So my first element, my top, the element in the top left-hand corner, I'm going to get, I need to do the top row of A dotted with the first column of B. So I have 1, 2, dotted with 5, 7. Doing that dot product. Oops, I didn't need that line. Have it. So used to writing fractions. That's not supposed to be a fraction. Okay. So the dot product just says multiply the first 2 elements plus multiply the second 2 elements. So 1 times 5 plus 2 times 7. So we just have 5 plus 14. 5 plus 14 is 19. So you can see here, we get 19 as our first element. Then to get our second element, we're going to take, we're still in the first row, so we're going to still use the first row of A, but this time times the second column of B. So first row of A times the second column of B. Sorry, it's covering the words there. But we get 1 times 6 plus 2 times 8. So first plus multiplying the second. So that's 6 plus 16, which is your 22 here. All right. So then to get this next one, now we're in the second row of A and the first, so we're in the second row in the first column. So we need the second row of A and the first column of B. So whatever the location of this one is, the one that you're looking for, you need that, that row of A and that column of B. So this is first row, second row, first column. So we need the second row of A, first column of B. So that would be 3 times 5 plus 4 times 7. Three times 5 plus 4 times 7. So 15 plus 28. And we get our 43 that they have here. All right, the last one, we're doing, we're in second row, second column. So second row of A, second column of B. So 3 times 6 plus 4 times 8. All right, multiply, add, and we get 50. So that's the basic strategy. That's how we figure out matrix multiplication. It's a lot of little pieces. I think that's honestly the hardest part of this is it's a lot of little pieces. You have to remember which row, which column you're in. If you need to write it out like this so you don't forget where you are, you can do that. If you can remember and do it in your head, that's fine. But if you need to write out, okay, this is the row I'm working on, this is the column I'm working on, if you need to do that, by all means, do that. Okay, So I'm going to do this example in the next video.